this is an exponential equation where we have to solve for x. It's the kind of exponential equation where we don't have compatible bases, meaning we can't change one base and rewrite it in terms of the other without some form of a decimal. So if we can't use integers, there's still a way we can do this. You can either use common logarithms or natural logarithms. ln is the natural logarithm. We'll take the natural logarithm of both sides. So we're writing ln on both sides in front of the terms. Now, it's helpful to put these in parentheses because it's not just one term in each exponent, it's two. And just to go back to why this is an exponential equation, it's because the variable that we're trying to solve is in the exponent position. But we need it to just be on one side by itself equal to everything else. Everything else can be on the right side, but the x needs to be on one side by itself. Here, now that we have ln in front of both of these, we can use the properties of logarithms to bring the exponent down to the front on both sides. So you'd say 2x plus 5, and this is why it's important to put this in parentheses. You don't want to accidentally put this only with the 5. It's being applied to the 2x as well. Same thing here. The ln2 is being applied to both of these, not just -7. So here, because their x is on both sides and they're both in parentheses, what we need to do now is distribute. I'm going to change these so the next step is easier to see. But you distribute it to both. You can write it like this. There's a 2x with its own ln7 plus the 5 with its own ln7. And it's helpful to sort of distinguish this so it doesn't look like 51. Here it's in yellow, so it's easy to see that it's definitely not 51. It's helpful to do that. Also, I kept a space between the plus and the argument here so that we can distinguish that the 7 is its own argument, which you can also put in parentheses if you want. But the important thing is not to put all of this together with the 7 as if they're all in the argument together there. But as far as writing it, we can just keep it simple. If we write it neatly, we can keep it like this. Here, the ln2 also gets distributed to both of these terms. You have the x ln2 minus 7 times the ln of 2. Next, we're looking for where the x terms are. Here's one, here's the other. We want the x terms to be on the same side. Anything that isn't an x side will need to go to the other side. And you can move both at the same time. But I'm going to move the x term first to the left side. So now, just to show it step by step, we have the 2x ln7 minus the x ln2. This we could have moved to the other side at the same time. And if you don't do that at the same time, you could just do it now. You move this to the other side now. So you have 2x ln7 minus x ln2. Here on the right side, you can put either one first, but I'll just go in order, where I'll put this one that moved over, I'll move it over here and put it at the end. Specifically on the left side, now we're trying to factor out x and nothing else. There could be sometimes where a GCF appears where you can factor out more than x, but you only want to factor out x. If you want, it might help to put this in parentheses to see the factoring step. The idea is that they both have an x. So for both of them, you're taking the x out and you're putting it outside the parentheses. All that's left now is the 2 ln7 minus the ln2. And these are the same colors, so I'm just being careful to make sure this doesn't look like 51. And I'm putting this up here so there's more space.
Okay, got you.
Alright, so once you have this in parentheses with the x factored out, this whole part in the parentheses needs to be divided from this side. And it's an equation, so you end up dividing both sides by it. On the left, I went ahead and wrote the denominator in parentheses, but once it's on the right side, we don't need that. We could just write it like this. And this part that's highlighted, this cancels out. It's dividing itself out. So all we have left is x equal to everything else. That's what we're trying to get. The x is by itself on one side. This is the exact form. So if you just needed the exact form, this would be it. But if you had to find the decimal approximation, maybe to, for example, 4 decimal places, you could either put it this way in your calculator. You'd have to carefully put the right number of parentheses. For example, if you're putting it as a fraction in your calculator and it let you put it exactly like this, you'd be all set. Or if you had to do it sideways, you'd put another set of parentheses around the top and the bottom, so the numerator and denominator are properly understood by the calculator. So if you wrote it sideways, you would have a set of parentheses on the outside for the numerator. Then you'd have the internal parentheses anyway for the arguments. And then you'd use the division button. It might look like this in the calculator. Then you open up another layer of parentheses for the entire denominator. A lot of people forget this part, and so then they don't get the right number because they forget about putting the extra layer of parentheses. But it's important. Without the extra layers, the calculator won't be able to read it correctly. Now let's find out what this is. And this part where I wrote it sideways, you can just enter it exactly like that. And the majority of calculators that we're using should be able to understand it exactly how you intend. But if not, if you have one where you have to do things in a different sequence, then definitely practice with the one that you're planning to use. Now, if I do it the way on the top, and I round to 4 decimal places, get negative 4.5586. Now I'll do it the way I wrote it sideways here, just to make sure. Alright, so the reason you want to make sure is because after doing all that work, it's very easy to typo this in the calculator. So instead, I just checked it in 2 different ways and I got the same decimal approximation twice. So this one, these answers in the box, these would be the decimal approximations, but these are different ways you can write the answer. Alright, for this one, do you have any questions about anything?
No questions.
So, definitely a longer question. You just want to be careful and go through this one slowly enough so that everything is there. It's easy on this one for there to be a mistake.
Got you.